5, 4, 3, 2, 1.
The gold standard for all surveys and polls is a random sample of the population. This was the area where developments in the late 1930s and throughout the 1940s really became important as social scientists and statisticians learned for the first time how to construct a genuine probability sample of the entire population of the country. The problem with that is it's relatively expensive, especially when we're talking about face-to-face samples. So the advent of telephone samples produced a new problem in random sampling: how to sample the entire population of telephone households. But interestingly, that turns out not to be as hard as you might think it would be. The idea is you can get a list of all the area codes in the country. You can also get a list of all the working exchanges, or so-called central office codes. Those are the first 3 digits of your phone number. So 608-263 is the area code and central office code that the university is connected to. Then generate the last 4 digits of the phone number completely at random. That random set of the last 4 digits provides every working number in the country a known and equal probability of being selected into your sample. The result is a random sample of the population as a whole, even though there's no universal phone book that lists every number in the country. It also has the advantage of including unlisted numbers, and so whether you have a listed number or not, you're still equally likely to be selected into a random digit dialed RDD, it's the term, a random digit dialed telephone sample. So this is the advantage. The trouble is that in recent years, response rates to RDD samples have continued to fall. As late as the 1980s, you might expect to get a 50 to 70% response rate from a telephone sample. But now, that's much less likely. Now, response rates to RDD samples have fallen into the 20% range or even below that. That low response rate concerns survey researchers because, after all, you don't know who's not responding. They're clearly not included in the survey. You don't know what their characteristics are. Sometimes we choose non-randomly selected numbers. The easiest example of that is a listed sample that's based on the registered voter lists. You can go to your county courthouse and buy a list of all registered voters in the county. The trouble is that that list doesn't include their phone numbers. So at that point you have to go to a business which specializes in matching names with phone numbers. That'll give you somewhere between a 70 and 85% match rate, but it's no longer a universal sample or a purely random sample of the population. Finally, one other way to do non-random samples are internet samples. Here, people volunteer to take part in the survey, possibly after being contacted by email or a website or an ad, and sometimes offered money or other rewards for taking part in the internet sample. But there, you have no control over who joins your survey, and therefore you have no probability basis for the inferences. That leads people who do work in internet surveys to rely on a variety of statistical techniques to adjust a non-random sample to match the distribution of characteristics we know in the full population. Unfortunately, how good that match is and how representative of the full population the people who agree to be in internet samples are is a more significant problem. And it's led to some internet surveys being consistently and wildly wrong, while other internet-based surveys are surprisingly close to the results we get with random digit dial telephone surveys. In all these cases, you should always know what population was sampled, how they were sampled, and where, if at all, departures from pure probability surveys, where were those kinds of trade-offs made, and what are the implications they might have for the quality of your sample.
For swimmers' health, please do not feed the duck.